All right, this one says the trees in the forest are being cut down at a monthly rate of 3.2%. This situation can be modeled by an exponential function. The forest contains 5,500 trees when cutting began. So if this is when it began, what can I talk about? What can I say about that 5,500 in regards to exponential functions? That represents my what? Y-intercept, but also your initial value. Reminder that when you're looking for initial value, and this is the formula we studied, your initial value or your y-intercept is always the first thing listed. Okay, so which one has 5,500 in the correct spot? All of them do. All right, so then you say, okay, and sometimes you'll be able to eliminate some options, and if you can, please do so. But then we have that 3.2%. Reminder, when anytime it's in percent, you need to convert it to a decimal. I can't underline up there, it's being covered. Why aren't you moving? Give me a second. All right, so we are looking at that 3.2%. So 3.2, and you can either do 3.2, move it to the left 2. So that would be 0.032, or you can do 0.32, or 3.2, sorry, divided by 100, right? Because that's percent out of percent. And it'll also convert it to a decimal. Now, 0.032 is your decimal. You still have to add or subtract from 1. If we're cutting down trees, it says what function can be used to decide how many trees of the forest there are at the end. Am I increasing the trees or decreasing the amount of trees? Decreasing. Should I add the 1 or subtract the 1? All right, so what's 1 minus 0.032? Subtract it for me. What do we get? 1 minus 0.032. Yeah, 0.968. Now, we know it's not going to be that decimal. We know it's not going to be greater than 1. So we could have picked that one using those pieces of knowledge as well. All right. Again, we can solve this by actually multiplying and doing all of our operations. What else have we looked at to kind of help us on that STAAR test? What else could I use for this step? InSolve. So you can just, remember, you type the word InSolve, so I'm going to let you do it without me. You put all of this in parentheses, all of it, the whole thing. What is the key factor with InSolve, though? What can you not forget? The comma, and then whatever letter you're looking for. So that comma X has to be listed at the very end. So let me give you a minute to figure that out for me. Which one? 30? All right, 30 it is. All right, let's go and go over to lesson 5. We're going to be looking at domain and range. Looking at domain and range. So the most important thing with domain and range to kind of help you out is just know what goes with what. Alphabetically, they line up the same way. X comes before Y, D comes before R, if you forget, okay? Domain goes with the X's, range goes with the Y's. Now, at the bottom here, these are continuous graphs because they're continuing. The line continues all the way through. Your range here is at negative 5.5 to 5. So it's at negative 5.5 all the way to 5, right? Because your range is your Y's. Your domain, mind you, these are your X's. So what is the minimum X values that this graph has to be? What number would that be there? Negative 5, right? So when you're looking at the range, you're looking at how wide it is. It goes from here to here. That's how wide my graph is. So you're just giving me those values. So I have a negative 5 here, and then I have a positive 5 here. So you're going to say negative 5 to 5. Always point to the left because these are in order from smallest to largest. And these are your X's. Now, do y'all remember which one has the equal sign? Is it the open dot or the closed dot? The closed dot, good. Closed dots have the equal sign. Should I put the equal sign with the negative 5 or the positive 5? The positive 5. Good. All right, make a little note up here. Just solids would have your equal sign. And then the open one would not have the equal sign, right? Just in case you need that refresher on that. Now, with this one, the domain is all real numbers. That domain's wrong. That's not all real numbers. What's the domain, if you're looking at your x's, it goes from 3. And then, does it get bigger or smaller? Bigger. So this one should be that your x's get bigger than 3. That's all it should be. That is incorrect. I need to make sure I fix that. And then, for your range at the bottom, what is your smallest y value? 4? So it's going to be at 4, and is it going to increase or decrease? Increase. All right, so your y's are going to get greater than 4. Should I put an equal sign on the 4? No, because it's an open circle. All right, so just remember, domains are x's, ranges are y's. Continuous graphs are connected. Discrete graphs are like scatter plots. They're just little dots everywhere. It says these are graphs that are disconnected or distinct points. Reminder, when you do domain and range with these, you list the points. That's all you do. You list the points. What points would be in my domain? Like what values would be in my domain? You start at the one to the farthest left, which happens to be this one. What's that x value? It would be -4. What else would I have? -3. -3, -1, and 0. That 0 snuck in there. All right, and then we'll do the same thing with the y's. You're going to take your point, take your lowest one, take it to the y-axis. I see -4 here, followed by -1, followed by 2, then 5, and the last one would be 8. All right, so those are listed differently. So if they're in just dots, not connected, those are going to be just numbers listed. All right, we only have 3 examples on our notes, okay? First one says, what is the range of this function for the situation? So let's see. It just wants to know the range. Are your ranges your x's or your y's? Your y's. All right, let's just focus on the y's. What's your smallest y it could be? 0. You take this point, slide it over, would be here. And then what's the highest it could be? 100. So you're going from 0 to 100. Which one has 0 to 100? B. All right, so just remember, domain and range, x and y, same order. All right, next one says, a quadratic function is graphed on the grid. Which answer choice best represents the domain and the range? What's the domain here? We talked about this. All real numbers, good. So on domain, let's find the one that says all real numbers. I see that B has it. Just B, right? That's it. Once you know that one, now you, if there were 2, you can check your range. Your range, it hits 3, but then it gets smaller. So that one does match. Your range is getting smaller. All right, and that's if there were 2, right? If it's one like this one, find that first answer. You can go ahead and select it from there. And then the last one, it says, what statement about the function that's given is true? What type of graph is this going to give me? Do y'all know? Good. A U, half a U, or a straight line? It's a complete U. It's going to either look like this or look like this. Do you remember which one determines if it goes down? What has to be true about the equation? It has to be a negative. If it's a negative, then it has to be pointing down. This one's your positive. Is this a negative equation or a positive equation? Positive, okay? So if it's like this, what has to be true about your domain? Your domain has to be all real numbers. All right, so domain is greater than 3, it has to be false. Domain is greater than 0, has to be false. So the domains are wrong. So now let's just check which one is true about the range. All right, so let me go and take out the calculator. Go ahead and graph this. All right. Give y'all a minute to graph this. All right, remember, always open up a new document. Let's see, we have x squared minus 6x, and then minus 16. Should the range be greater than negative 25 or greater than negative 1? Well, if I look at my graph now, is it hitting, is it at the negative 1? No, I can zoom out.
She's zooming.
I sure am, aren't I? Okay. All right, now we can trace it from here. If you want to hit menu trace and then go to your left, we see that my lowest y value is the negative 25. So that one should be choice B. Before I let you go, let me talk about this vertex real quick. The vertex here was 3, negative 25, right? Now, do y'all remember what the 3 tells me? What does the 3 tell me? The 3 tells me that that is the what? Axis of symmetry. This is going to give you your minimum or maximum value. In this case, it's a minimum value. It's negative 25. It also gives you your range. Your range has to be y to negative 25, and then you look at your graph and you decide, okay, are my y's getting bigger or smaller? Well, your y's are getting what? Bigger. All right, I'm just pointing it out just so y'all remember that if you buy your vertex, you guys can figure those pieces out, okay?